In this first video for section 6.1 notes, we're going to talk about discrete random variables, how to determine what a sample space and a probability distribution is of that discrete random variable. We're also going to talk about the requirements for a distribution and find some probabilities within a distribution as well. So, first I can statement, you're going to be able to compute probabilities using the probability distribution of a discrete random variable. And you notice the title of this section is discrete and continuous random variables. These are very different things. Discrete and continuous, much like just numbers in general. Discrete means you can count the numbers themselves. So 1, 2, 3, 4, 5, 6, 7, 8. And then continuous, there's an uncountable number list. So that could be something like the unit of time, where you can always get more and more accurate measurements. You can't really count time unless you state that you can only count in whole numbers of seconds. You know, you can always have 1.000001 seconds or 1.00000001 and so on. That's the continuous part, and it's uncountable. The first thing we're talking about is discrete, in that we have a countable list here. The first example of a discrete random variable is the sample space for tossing a coin 3 times. So 3 times, 2 outcomes per time, 2 to the third power. You're going to have 8 outcomes here. Okay? They are heads, 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 tails, heads, tails, heads, tails, heads, heads, tail, tail, heads, tail, heads, tail, heads, tails, tail, and tails, tails, tail. That's 1, 4, and that's 8. All right? Now, if there's 8 outcomes and they're all equally likely, each one of these is 1/8 probability of happening. X equals 0, X equals 1, 2, 3. We're going to define X as getting a heads when you flip a coin. So if X equals 0, that means there are no heads. And there's only one of those. That's when you get all 3 tails. X equals 1. How many of these have 1 heads in them? Well, there's tails, heads, tails, 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 heads, and head, tails, tails. 2 heads, there's 3 of those. Heads, heads, tails, heads, tails, heads, and tails, heads, heads. And X equals 3, there's heads, heads, heads. Still a total of 8, but these 2 have 3 outcomes, and these only have 1 each. So this is what a probability distribution looks like. It is the possible values for the random variable and the probability of each. So the probability of getting 0 heads is only 1 out of 8. There's only one way to get 0 heads. Getting 1 heads, there are 3 outcomes, so therefore it's 3 out of 8. X equals 2, 3 outcomes, 3 out of 8 is the probability. 3 heads, only one way, 1 out of 8. And to check its legitimacy, 1/8 plus 3/8 plus 3/8 plus 1/8 will add up to 1 or 100%. That has to be true for any probability distribution. All right, so let's define what a random variable is. It's a numerical value or values that describe the outcomes of some chance process. It can be any letter, but we're going to usually choose X, where you make it capitalized. It could be Y, it could be Z, D, T, whatever it is, but either the book will name it, or the test will name it, or you'll have to come up with it on your own. The probability distribution does 2 things. First, gives the possible values for random variable X, or whatever it's called. So what are the possible values? Could be finite or infinite. 2, it also gives each of the probabilities. So those 2 things, all the possible values of the random variable and then each of their respective probabilities. So this is what it looks like. It's a table. The top row will be the values. Probability will be down here for each of those. Okay. The 2 rules. Every probability that's listed here must be between 0 and 1. And we've already talked about this, but the sum of the probabilities, all of them together, have to add up to 1. That's why these 4 add up to 1, showing its legitimacy. 1/8, 3/8, 3/8, and 1/8 adds up to 1. In our book, they have a test for infants called the APGAR test, and it's a series of 5 tests that you can score a 0, 1, or 2 on. So the minimum score total out of the 5 tests is 0, and the maximum is a 10. And then they have the probability of a baby getting, or an infant getting, any one of these scores in between. So 0, 1, 2, 3, all the way up to 10. Just by looking at the probabilities, you can kind of see these are really, really small probabilities. When you get to about 6, 7, up to 9, 10, this is where the majority of the data is actually going to appear. And in our book and on the notes, there's an actual histogram showing that. The majority, or the biggest chunk of data, is right here. So majority of babies or infant scores are right here in the graph. Examples here: state in words what each probability means, then find the following probabilities. So this is just a way of making sure you understand the context of the problem and restating it when you see something like this. P is parentheses, P of parentheses X is less than 1. Essentially just means less than 1 on APGAR test. Just a simple statement, less than 1s, that should be obvious. APGAR test, as long as you know what problem you're referring to in this case, that's all you got to write down. All right. Finding the probability, discrete, you simply just find the probabilities that follow the rules here. X is less than 1. It's a strict sign, so you're not including 1. You could also write this as probability of X equals 0, because that's the only thing less than 1 is 0. Now the probability is this underneath here, 0.001. You're not going to write this as your probability. The number underneath is the probability. This is just the value of the random variable. B, probability of X is greater than 3. You have 2 different options here for finding the probability. But first, we could just say it's score of more than 3 on the APGAR test. That would be a simple statement you could write down. 2 options though. Greater than 3, not included. So that's 4, 5, 6, 7, 8, 9, 10. All of those probabilities add up together. So that's a total of 4 to 10. That's 7. So if you add those 7 probabilities up, you would get the probability of X is greater than 3. One option is to do that. The other option is to find the complement of that. So this is really equal to 1 minus the probability of X is less than or equal to 3. Because the probability of less than or equal to 3 is 3 and below, and this greater than 3 is 4 and above. Those together make up 1 or 100%. So you're finding the complement, you have a little bit less work to do. Probability of less than or equal to 3, that's 1, 2, 3, 4 to add together, rather than 1, 2, 3, 4, 5, 6, 7 to add together. And it doesn't matter which way you do it. I'm just going to show you this one way. These are the 4 probabilities I'm getting from the table, 0 through 3. All right, 0.001, 0.001, 0.006, 0.006, and so on. When you do your math there, you get 0.978, or you can write it as a percentage. Doesn't matter to me, 97.8%. Probability of less than or equal to 2. You should know this phrase, at most 2 on APGAR test. The at most part. So at the very highest, it's going to be 2 or less than that. That's what the at most 2 means. So probability of less than or equal to 2. That's everything less than or equal to 2. So 0, 1, and 2. That's only 3 of them. So 001, 006, 007, 014. So let's take a look at the graph again, the histogram. It is a skewed left graph. So if we're describing shape, center, and spread, I'm going to follow the rules from previous chapters about how to describe those. Shape, we just said, was skewed left. Center. If we're going to describe the center here, we're going to use the median because it is skewed. And the median is actually at 8. And how we know this is that the data total is 100% or 1. The halfway point we know for probabilities is going to then be 50% or 0.5. If you count these numbers up that correspond to these bars in this table, If you were to count up and keep adding and adding the numbers, cumulative probability, it doesn't cross the 0.5 or 50% threshold once you get to 8. If you add all the numbers up to 7, you're still below 0.5. Once you add 8, though, that probability, you get to 0.52 approximately, and that's how you know it's your median, it's your middle number. And then spread, we don't know very much about the standard deviation yet, so we're just going to do the range, 0 to 10. We also just want to maybe say majority of data is in between 7 and 10. It's the biggest chunk of data there. 2, a score of 7 or higher means that the baby will be healthy. What is the probability of a randomly selected baby being healthy? So, find the probability. In terms of the context, you're looking for the probability of a healthy baby. Well, if you didn't have this problem here, you wouldn't know what that is. Luckily for us, it's written right here, at least a score of 7 or 7 or higher. So essentially what you're finding here is x is greater than or equal to 7. So this is the context of the problem. This is just the bare bones math about it. X is greater than or equal to 7. So that's 7, 8, 9, and 10 you got to add together. So 0.099, 0.319, 0.437, 0.053, and that total probability is 0.908 or 90.8%. So the probability of randomly selecting a baby being healthy is 90.8% or almost 91%. So this is how you find probabilities using a probability distribution. You could find greater than or equal to, greater than. You could just find a probability of a single one by identifying it in the table. Whatever it asks of you, just simply follow the rules. Either you could use the complement if that's an option for you, or just add each individual piece depending on the inequality given to you in each one of these problems. This is how it works for a discrete random variable. And that's the ICANN statement we finished from the front. In the second video, we're going to talk about mean, expected value, and standard deviation of a discrete random variable.